Let's have a look at road and storm drain and water and sanitary sewer. Okay, roads need a good driving surface. A simple road might have a gravel surface. A better road might have a driving surface of asphalt, which is a mixture of real heavy crude oil and gravel, or concrete, which is a mixture of cement and aggregate, which is another word for gravel and sand and things like that. Roads are built at a certain grade. This is very carefully controlled. The grade is the slope of the road. You can't build a grade too much lower than 0.35%, which would be a grade of 0.0035. You just can't control it any better than that, so you would have puddles and things forming if you attempted to go much lower than that. The highest grades are controlled by the ability to climb up the road or to brake when you go down it. And that depends on the type of road that you're building. You know, a large interstate, I don't know, maybe 3% grades is what they're looking for on that. Smaller roads can be built at steeper grades. 10% is a pretty good highest possible grade for a reasonable road. I've seen some steeper just because they have to be going up a hill, but that's getting at the upper limit there. All right, there's a typical road cross-section. A big part of this design is just to get a good stable foundation for the road, and also to keep water out of what we call the subgrade, which is the fill, the rock fill below the driving surface. Water in there will weaken it and can cause a lot of problems with the subgrade or fill. So roads are crowned usually, and the idea there is so that they will shed water when it rains. So you just don't want puddles of water forming on your road. That's just trouble. So they've got a cross slope on them to get the water off the road into the gutter if there's a gutter on the road. All right, you do have to have a way of controlling the flow of water on a road. Two common methods are used. Curb and gutter is used on residential and city type roads. The idea there is to sink the road into the ground a little bit, and then what you want to do with your design on the road is get the water into the gutter. The gutter is then made of concrete and can be very precisely controlled when it's graded. So what you can do then is get that to drain away and take the water where you want it to go. Okay, these roads are set down a little bit here into the ground. So the idea is they serve as drainage conduits for the surrounding ground. So generally speaking, a curb and gutter road, usually it's set low. The idea is to get the runoff from the surrounding ground. Okay, so you've got that water coming in, you've got the water from the crown of the road going into the gutter, so everything's put into the gutter. The curb kind of serves as a back wall in the gutter, and then the water is channeled to where it needs to go. Another way to do this is to use ditches on the side of the road, like a county type road. These types of roads are usually used out in the country, and what you would have then is the road up higher. You want to get it out and away from the water. Then you have a ditch along the side of the road, so when the water comes from the side, it'll get into the ditch. The road is also crowned, and there you see a bit of a shoulder. You see that nice fill there. The road's going to slide or move off the crowned road and into the ditch also. This requires the use of culverts to cross over, driveways and other roads and things. And then as you'll notice here that stuff gets pulled in with the water into the ditch. All right, there's the basic cross section of a road. You see the curb and gutter on either side. You have the driving surface, asphalt, concrete. Those are impermeable surfaces that shed water. There's also gravel that's used for roads. You then have a good quality gravel underneath. Usually you can't use the native soil, the soil that's there. You have to excavate a certain amount of that, get rid of it, and bring in good quality crushed rock, usually that has some fines and sand in it, so it can be compacted and be a very strong foundation. Nowadays, underneath a road, we put in something called filter fabric or geotextile. It's a woven synthetic fabric, and it creates a barrier between the good clean fill and the existing ground beneath. That prevents the fill from getting contaminated by the soil underneath, but also allows water to move out of the fill if it has any gotten into the fill to begin with. Okay, here you see a road project. This is kind of half a road that was built. You can see there they've excavated the native soil. You notice kind of that brown color of the native soil. And then you see they've got some geotextile over here ready to spread out. So that's the starting point there. So they've excavated the native soil. Okay, here they've spread the geotextile right there. And then they're starting to bring in their nice clean fill on top of it. So that's crushed gravel there. It also has sand and just a little bit of silt to help it compact properly. You see a roller there that vibrates and compacts that soil. They'll get the fill, I should say. They'll get the fill to the optimum moisture content and then compact it repeatedly to get it good and strong so that it won't compact on its own later and will create a very good, strong foundation for the road. Okay, they've got more what we call lifts of their fill material in there. Looks like they're starting to pave. They've got some rough paving in there now. You see they haven't quite brought that up to the level that they need. They'll bring in a second what's called lift, which means a layer of asphalt there to get that up to the level of the pavement on the other side. You also see the curb has been built along the side right there. And it looks like they've got some fill ready to go there for a sidewalk. Okay, fill is, as I say, your last layer of fill should be 3/4 inch minus crushed rock with sand and just a little bit of silt in there. It's important to compact that properly, so you put it in what are called lifts, which is another word for layer, 6 inches to 12 inches thick, and then they're compacted as you go. You don't want to put down a lot of fill and try and compact a very thick lift or thick layer all at once because it's very difficult to do. You probably wouldn't be successful at that. So you bring the fill in layers 6 to 12 inches, compact as you go. That ensures good, strong compaction. If you fail to compact the soil, the fill, again, I should say the fill, or if it has clay in it, it'll start to fail a little bit, and that usually ends up in having a pothole. Pothole isn't necessarily indicative of bad asphalt on top. It means the fill is fallen down below the asphalt. You get kind of an empty pocket in there, and the asphalt isn't strong enough on its own to hold up. So eventually you get a pothole in there. Now it can be bad asphalt, but quite often it's bad or poorly compacted fill underneath that causes the pothole. All right, as you go, you pay a certain amount of attention to what we call curb returns. This is really how you control the grade on the road. Is you start building with the curbs. You can really precisely control the elevation of the curbs because they're made out of concrete and are quite often built with formwork. So you can really control those very precisely. You have to pay a lot of attention to what are called curb returns, which is when the curbs go around rounded corners. And you want to be sure that they're built properly, and you want to be taking a careful look at what we call the top of curb elevations at the beginning and end, just to make sure that they'll drain properly. You've got to have enough grade on those curb returns so that the water drains around them properly. So you look at those top of curb elevations and make sure you've got a steep enough grade for the water to move around those curb returns and to go where you want it to go. Okay, here's that same job I was showing you. They're set up to do that curb return. They've used a flexible PVC pipe on these stands here. That'll guide their curb machine as it goes around that curb return. Okay, there's some curb returns that have been put in right there, so that's the term for that. Here you see the pattern on this. The gutter will drain down this way, and there you see a catch basin there. So that would be the low point of the curb, and that's where you're going to direct the water to the low point, and then you have that catch basin, which is a box that'll pick up the water and then can be piped to a manhole and from there out into a receiving stream. All right. Now the storm drain then is very closely tied into the curb. You want to look at where the low points are of your road and then put curb inlets there or catch basins, either one. They're boxes that pick up the runoff water, the storm drainage, and then from there it goes to the manhole, from there to a pipe, and eventually through the system and into a river or a creek or a lake or a pond or something like that to get the water where it needs to go. Okay. Now, one system of storm drainage involves ditches and culverts. Anytime you've got a driveway or another crossroad blocking the ditch, you'd put a culvert in there to pipe the water under the driveway or ditch. There's a culvert right there. Okay, here's another culvert. You see the two ends of that as it crosses that little driveway access, what do you want to call that, to a fire hydrant there. But you can see the culvert on either side of that little bit of fill. So again, the purpose of that is just to get the water under the fill, like so. All right, now you have to get, if you have curb and gutter, you have to get the water from the gutter into this system here. So the first thing that does that is either a curb inlet, which is set into the curb. You see the water would come around there. So this would be set at the low point of the gutter. You can see right here all the stuff that comes in with the water, so that you have to maintain these and prevent them from being clogged. Okay, here's a catch basin, a similar device, except the main idea here is the water drops in through the gutter. So basically a curb inlet, the water enters through the curb. Catch basin, the water enters through the gutter. They're similar things. They're both just concrete boxes with pipes coming out of them. This is also a curb inlet because you see the curb inlet portion right there, and again you see all that trash that gets carried in with the water. All right, from there you have a pipe that goes to the manhole. Now typically storm drainage pipe is green PVC, ASTM 3034. So ASTM is American Society of Testing Materials. 3034 is the designation for that particular type of pipe. The SDR 35 here references the wall thickness. All right, now if you need extra strength in your pipes, you can use concrete pipe. You might use this, they're used for culverts fairly commonly around here because you don't have much cover on the culverts. You like to get 3 feet of good fill above pipes. It keeps them from being crushed. If you can't get that, it's quite common to go with concrete because it's a stronger pipe. So if you can't get your 3 feet on a culvert, which is very, very common, you'd very often use a concrete culvert. But also on storm drain lines in the road, if you can't get that good amount of cover on them, you might go with concrete. It's more expensive and it's heavier and harder to deal with, but it's stronger and sometimes you need the strength. Okay, on storm drain lines, you use push-on joints, much easier to assemble underground. So you've got just a plain end pipe and then a bell end with a gasket that you can join when you're laying pipe in the trench. So that's the type of joint used on storm drains. Okay, so from the curb inlet or catch basin, the water then flows to a manhole. A manhole is consists of a base with the pipe running through it. The pipe drops across the base, so you can tell here that this particular line is flowing that way. Okay, that'll be put in place. The pipes will be attached, and then there'll be a grouted channels put in there to get the water across the base. You then put in, these things are usually 4-foot diameter. You put rings that are kind of a tongue and groove, not quite tongue and groove, but that's kind of the idea. And they have these mastic sort of gaskets that fit around them. You stack as many rings as you need. Then you get to a cone. Okay, the cone goes from 4-foot diameter to a 2-foot diameter, and then the metal frame and lid sit on the top. So that's the basic way you put a manhole together. It's just a series of the base, as many 2-foot high rings as you need, then you neck down from that large 4-foot diameter ring down to a 2-foot lid and frame and lid on the top. Those cones, I think, are about 3 feet, if I remember right. I think it might be 4, but I think it's about 3. So there's the top of a manhole. This particular one's sticking up out of the ground, which they don't usually do, but you can see the cone there. And then there's the frame and the lid on the top. Okay, the pipe should drop 1/10 of a foot across a manhole, which gets the flow going efficiently across the manhole. So the invert being the flow line of the pipe, the in invert should be 1/10 of a foot higher than the out inverts. 1/10 of a foot is just a little bit more than an inch. So you get a little bit of fall across these manholes to get the flow working properly. You'll then go into the manhole, pour in some grout, and use trowels to get a nice smooth channel to connect the pipes in to the pipe out. Okay, so that gets efficient flow going across the manhole. They also use neoprene, these black dense rubber pipe boots. They precast holes in the manhole ring where the pipes are going to go. The boot then kind of expands out and fits into that hole. Then you put the pipe in the boot. The boot kind of necks down to the size of the pipe, and then there's just kind of a device there that you can tighten and get the boot securely attached to the pipe. This gives the pipe a little bit of give here, so you're not breaking pipes off. Would be a real good idea, certainly in an earthquake event, to have that flexibility there. Just a better connection there instead of just grouting the pipe into the manhole or something. So this is pretty commonly used now, these neoprene pipe boots. Okay, ditches and culverts are also used for stormwater. Now the stormwater then goes directly to a receiving stream, a river, stream, pond, lake, etc. So you're getting all this runoff. It goes down into a catch basin, from there into a manhole, and then you've got a discharge into the receiving stream, which leads to some problems because you can get pollution going right from the street and the surrounding area right into the streams. You don't want that to happen. There's been more and more emphasis on stormwater treatment, in the past, I don't know, 10 or 20 years. There's been more focus on it. There's various ways of doing this. Some of the basic methods on these catch basins and curb inlets, those are concrete boxes. Well, you build them extra deep. The idea there is when the water flows in, the grit and the sand and all the stuff that kind of comes in there has a lot of the pollutants attached to it. A lot of oil and grease attaches to the grit. If you leave a sump in there, by building that extra deep, the grit will just build up in the bottom of the catch basin. The water then will be on top and will go through the pipe. So if you leave a bit of a sump in there, that grit will collect. You then have to do the maintenance and bring a Vactor truck in and clean those out periodically to get that grit out of there. So this is one of the basic treatment methods. Okay, here you see a catch basin. Kind of hard to make this out, I know, but great there. There's a little bit of a lid there that fits over the pipe. So the idea there is to force the water. So, this is going to be tough to draw here, but that lid kind of does that. So what you're doing is you're forcing the water to go down and then come back up to get into the pipe. That just makes that grit settle out more readily. Okay. All right, if you have a larger area, you can build a sedimentation basin, just a little bit of a pond. Have a break between the water flowing in and the water flowing out. The grit will then settle out. You also might get a little bit of treatment if you've got some plants growing in there too. They might help clean up the water. Oil and grease traps are also used. They're kind of like septic tanks. They have baffles in them. So you'd have the flow in, force it down, get the grit to settle out, force it up and over another baffle. You might get the oil and scum and such to kind of raise to the top, as oil will do, and then back down and out. And then again, the maintenance is very important on this. So by baffling these traps here, you can catch the sediment and the oil and grease more readily. But again, you have to get in there and clean those out for them to work effectively. Okay, they have made another step up if you start looking at newer roads that are built. Here you see the gutter with a grate on it. That water's going to come in here. They're going to get a bit of a splash pad so it doesn't tear up this little area here where the treatment will occur. And then just a little bit of an outlet there so the water will come into this sand filter, which is what this is. Once that water gets into the sand filter, it'll start to seep down through the sand, and the sand will filter it out. There'll be plants that'll grow there too that'll help to clean that up. Underneath this is a perforated pipe. So that's down below. The water will seep through that sand and get filtered out, get into the perforated pipe, and then is piped off to where it needs to go. Here you see a little bit of a graded standpipe, so if the thing starts to back up, the water has somewhere to go and will bypass the sand, but all the same, you won't have a big overflow happening there. So this is kind of the current state of higher end stormwater treatment using a sand filter with, and they'll put plants in here that will help filter the water as well. Okay, some cities have combined sewers. One pipe is both the sanitary sewer and the storm drain. Okay, so what that means is both the sewage from houses and the stormwater are run through the wastewater treatment plant for the city. Now that can be fine if you have the capacity, but if you have large rainstorms and big runoff events where you get a lot of water running on the streets, it can overwhelm the plant. And so quite often in those cases, the plant might have to bypass some of that flow, not treat it and discharge it directly into the river or stream or receiving stream. That can be a bit of a problem. So I think cities do prefer to have separate systems, one for the sewage coming from houses and businesses, etc., and another system for the stormwater. It's easier to keep those two flows separated because they're treated rather differently. But if you built your original system as a combined sewer, you have to deal with this. It would just be hugely expensive to try and change that to make it into two separate systems. All right, we have the water system as well. All right, water is the water system takes the water from the treatment plant to houses and businesses and things. So this is a large piping system. We start with a river, lake, reservoir, the ground. We make the water what's called potable, which means safe. I should say safe, not save. Safe to drink. And palatable, which means good appearance and taste and odor. That happens at a water treatment plant. Depending on your water source, you may have to treat the water more or less. It just depends on the condition of your source water and what type it is. Okay, water is used to do the common things we think about, drink, cook, and clean. But we also water lawns and plants with it. We play in it. We fight fires. Use it for cooling and for industrial purposes. Now, in the system in America, we have one system for all these different types of water. So we treat all of our water to make it safe to drink, even though we drink a very, very small percentage of the total water in the system. Okay, the water pipes are actually sized for firefighting, which is the largest required instantaneous flow that you have. So we have one system. Some countries don't. Some countries have drinking water that's separate from their water for these other purposes. And we size our lines primarily for fighting fires. Water lines are pressurized too, so that influences their design of the pipes in the whole system. All right, so you probably have water tanks somewhere within the city. They can be different types. This type is right at the ground level, so it's going to have a pump station next to it to pressurize the system. Some water tanks are up in the hills, which have elevation. Some are built in kind of a shape, bulb kind of shape, where they kind of have a standpipe and they'd have the bulb where most of the water is kept. That helps to pressurize the system if they're built that way. So water tanks have different designs depending on their function. They store water for the use by the city. They also usually have some method of pressurizing the water, either through elevation or they might have a pumping station attached to them. So there's just a simple pump there that would be a centrifugal pump that would be used to add pressure to the water. There's an elevated water tank which stores pressure. Okay, water lines are looped to improve the hydraulics. So the water line extends throughout most of the roads in the city and is looped in many different ways to get lots of different pathways for the water to travel through, because that just improves the hydraulic performance of the system. It gives more than one path for the water to get to the users. Okay, the water mains are the large pipes in the road. They're typically made of either ductile iron pipe, DIP, or PVC C900. Water mains typically around 8 inches in residential areas. I've seen them down at 6 or even 4 inches. But if you want to get effective firefighting in a larger residential area, you probably want to go with 8-inch mains. Smaller mains are sometimes used to travel down dead-end streets and things. Uh, you might have larger mains, for transmitting large amounts of water as well. 8-inch is fairly typical in a town like Albany. Okay, use push-on joints. Much easier to assemble these large heavy pipes in trenches in the ground with push-on joints. If you need extra strength, you can use mechanical joints and flange joints. Okay, flange is very rigid, very strong, but very hard to assemble underground. Mechanical joint, you can get a little bit of bend in there. It's easier to assemble, though it's not quite as strong. Okay, there's a series of fittings that go into the system. Just depending on what you're doing with your system, you might need a number of these intersections and T's and bends and reducers and things. Okay, thrust blocks are used at T's and bends. Here's a thrust block attached to the backside of a hydrant. If you have a pressurized water line, you're going to have pressure building up there and trying to push that hydrant off the pipe. So you can put a block of concrete behind that and attach that pipe to the back strong soil in the trench, and that will anchor that pipe to the back wall of the trench. That's just called a thrust block. Okay, you can also use more elaborate mechanical joints that have reinforcing systems in them too to get extra strength. That's another way to get extra strength. Valves are used to shut water lines down primarily. Gate valves are used on lines that are 10 inches and smaller, which is most of the lines. They're very nice because when you open them, they have no obstruction in the pipe. So when you open a gate valve, this disc here just lifts up, it gets out of the way, you've got a clean run through the pipe. They're used as on-off valves. They're not good for throttling flow. They're used to turn the flow on and off. So if you have a break in the line, you're going to have to locate where your valves are, shut them to isolate that section so you can work on it. So 10-inch and smaller gate valves are usually used. 12-inch and bigger, you probably use butterflies because they're cheaper. They do have, what happens is you turn the handle, that's going to be hard to do, but kind of like that, and that will turn that disc perpendicular to so it's parallel to the flow and pretty much open up the pipe. You will have that disc there in the pipe, which makes an obstruction, which is kind of a problem. But the gate valves just get very expensive when you start getting 12 inches and bigger. Okay, valve boxes sit on valves. Here's a valve. You notice that's flanged or mechanical jointed in for strength. It's got the operating nut right there that you can get a valve wrench on and turn to open the valve. Well, you need to access that, so you put what's called a valve box, which is actually a pipe that sits on that over that stem of the valve and gives you access to it. So that's called a valve box, even though it's a lot more like a pipe sticking up out of the ground. Normally they're flush with the road. So you can pull that cover, get a long stemmed valve wrench in there, or a long valve wrench on there, and turn that valve stem to open it up. There's other valves in the system, just depending on what your uses might be. There's air release, which allows put at high points of the line to release air. There's air and vacuum relief, which allow large amounts of air in and out when you're filling and draining a pipe. Globe valves are kind of modified to make elevation valves and pressure reducing valves. They control flow in and out of things and reduce pressures, obviously. Backflow valves prevent flow going in the wrong direction. They usually are used to prevent contaminated water from flowing into the drinking water system. Okay, there's a fire hydrant. They're very commonly used on water systems. They're used, of course, to fight fires, but they're also used to flush the lines. Once or twice a year, cities flush lines and they do that through the fire hydrants. They're also used as access points to monitor and clean water lines and to access large amounts of water for cleaning and doing that sort of thing if that's needed. All right, there's two basic types of hydrants. There's center stem, which has the operating nut in the middle of the stem. Cories have the nut over on the side. These are different styles of hydrants that have different valving systems down on the bottom there. When you install a fire hydrant, you put in a full assembly. What that is, if we have the main right there running in and out of the page, you'll put a T there, quite often a flange T, bolt a valve to that. On the back side of the valve, you often go to a mechanical joint fitting, run a spool of pipe, which is just a plain length of pipe in there, and then go into the foot of the hydrant, and then you have the riser on the hydrant, and you get up to the barrel up in here. So that's what a fire hydrant assembly looks like. So you'll have this valve here. Its function is to isolate the hydrant. So if you need to work on it, you can isolate it and reduce the pressure and shut it down, shut the water off going to it. Then you can work on the hydrant. The actual hydrant valve is down here, and that stem goes down so you can open and shut the valve in the actual hydrant. Okay, so here's the isolation valve, and then the valve of the hydrant is in the foot of the hydrant. Now, hydrants are used to flush lines. That's one of their main things. Now, if you have a small kind of a dead end road with a short run of pipe and you want to be able to flush it, but you don't need a hydrant, you can use something called a blow off, which is just cheaper than a hydrant. So what's going on here is they've kind of bolted a ring onto the pipe and then put a concrete anchor on there to kind of support all this so it doesn't get torn up by water hammer. They've got what they call a blind flange in there, which is a round plate that bolts on the back end of that pipe. It's tapped with a hole. Then you run out a smaller line, maybe a 2-inch line. You've got a 2-inch gate valve, which is going to be an awful lot cheaper than an 8-inch gate valve or something like that, or a 6-inch. So that's how you control the flow in it out of this thing. You can open up that gate valve then, and then you've got a riser pipe here with a cap on it. So you could open that up and flush this line. It's called a blow-off. It's used on dead-end streets that are kind of short. It's just a cheaper way of flushing a line as opposed to having to use a hydrant there, which would just be a lot more expensive thing to put on the end of a pipe. Okay, you have to get the water from the main to the customer, so you use a water service there. Typically, you put a saddle around the line. The saddle then has a fitting on there that you can screw what's called a corp stop into. So there's a saddle going around the line in red with the strap going around the pipe there. Okay, then you've got this on-off valve, a brass, what's called a corporation stop, called a corp stop. From there, you run the service line out of that. So here's the service line, typically somewhere around 1 inch diameter. Copper pipe is commonly used. PVC is used sometimes. Then you go to an angle stop, which is another valve there. And then you have the meter in the meter box. Okay, so that's what a service looks like when you're doing the public works water main construction. Okay, so you go saddle, typically, corp stop, go to the service line. Okay. Service lines these days are typically PVC. Type K copper, which is a soft, flexible copper, is probably the preferred type these days. Then you go to an angle stop, and that attaches to the meter. Okay, the meter then fits in a meter box, which is quite often in the sidewalk or somewhere along the edge of the road. And there's a meter box installed. Okay, so the meter will be in there, and so the pipe will probably, it's hard to tell, but probably come from this direction. You'll have the meter in here. You have an angle stop in there, goes into the meter, and then you have the line going out. There might be some other things in there as well. It just depends on what the city requires. So there we go. So there's the meter box with the angle stop in it and the meter. Then you've got an outlet with a valve on there. Okay, so the city will be responsible up until the meter box. Okay. On this side, it's the homeowner or whoever owns this property is responsible. Okay, so the city takes care of everything up to the meter box. The homeowner or whomever owns that lot takes care of the other side. So I worked for a little bit with the water distribution crew for the city of Albany. If someone calls complaining of low water pressure, what they would do is they would open up the box, shut this angle stop to shut down the system, pull the meter out and put a pressure gauge right there and read the pressure. They were looking for 20 psi. If they have less than 20 psi, they would have to work on their service line. Quite often they would just replace it just to fix everything. If they have 20 psi or greater, they contact the homeowner and politely let them know that they probably have a plumbing problem over here. Okay, so that's the boundary there between the city side and the homeowner side. Okay, the last utility here we'll look at is the sanitary sewer. That, if you have water going to these buildings, you need a system to get the wastewater out. Okay, so what you do is you have the wastewater piping in the house. That's going to run down usually to a 4-inch line that comes out of the house. Somewhere in there you want to clean out, if you can get one, which is just a place where you angle up to the surface of the ground. You'd have a cap on there, so if something's clogged, hopefully a plumber could get a snake in there and run that down. Ideally, there'd be a clean out also by the property line. That would serve as a nice boundary there between the city side and the homeowner side. Not always possible, but ideally that's what you would have. Okay. And so you just have this pipe running downhill. It'll drop down into the main, which runs in the street. You might have a saddle or a T or a TY or something in there to get the connection between the service line and the main. Service line might be something on the order of 4 inches. The main more like 8 inches. Okay, once you get the water into that large diameter sewer main, it's going to be this PVC ASTM 3034, SDR 35, just like storm drainage. 8-inch diameter typically. You need these lines to be pretty big so they don't clog up. You could use concrete pipe also if you need extra strength. You use push-on joints, so the building of this system is quite similar to storm drain systems. Anytime you have an intersection or a change in grade or direction, you need a manhole. So again, the manhole is very similar to what I described in the storm drain section. Okay, the pipes drop across the manholes, so the insides are typically 1/10 of a foot higher than the outsides. You grout the bottom of the manhole so that the flow in goes smoothly through the manhole and channels and gets to the out pipe. You use pipe boots, just as you do with storm drainage there, to make the connection between the pipe and the manhole. Okay, the water then just flows downhill until it does one of two things. Either it gets to the wastewater treatment plant where the water is treated and discharged. But if you keep having to run these pipes downhill, eventually, if you're on flat ground, you'll just get very, very deep with these sewer mains. This can also occur when you have to go over a rise in the ground, a hill or a ridge or something like that. Typically, from my experience, about 15 to 20 foot depth, you're going to need to put in what we call a lift station or a pump station. So what you would do then is have this wastewater coming in. It'll flow into a manhole. Typically at the bottom of the manhole, you've got one or very often two submersible pumps. As the level of this water rises in the manhole, it'll turn a switch on that'll turn that pump on, and it will pump the wastewater uphill to a second manhole to a more acceptable depth. This pipe then is pressurized. It's going to be built a lot like a water line because it's pressurized. And that's called a force main because you're forcing the water uphill through it. And so that's a lift station there. So what you do, you get the wastewater up to an acceptable level, and then you can start to have it flow by gravity again and go where it needs to go. Okay, there's a lift station. That's a duplex station there with two pumps. You've got switching there. As the water rises, the first pump will come on. If the water keeps rising, the second pump will come on. If the second pump doesn't keep up and the water rises, you got another switch there to turn on an alarm. As the water drops, you've got an off switch. Okay, so that's the basic setup on that. The water then goes to a wastewater treatment plant. This system keeps flowing towards the plant. A lot of these smaller mains collect on a large trunk sewer, which carries a lot of the flow for the whole city eventually as these mains collect, and then eventually get to the wastewater treatment plant, which treats the wastewater and then discharges the cleaner water into a river, lake, or the ocean. Okay, so that's a little bit more of a run through road, storm drain, water, and sewer.